What's up, guys? We're looking at simplifying rational expressions today. So go ahead, pause it, write down your target, your how, and your why. You should be able to, by the end of this, simplify rational expressions, basically by finding the GCF. All right, let's get right to it. So, a rational expression, or an algebraic fraction, is a fraction with a polynomial in the numerator and a non-zero polynomial in the denominator. So the reason we say non-zero is because we know we cannot divide by zero. If you try to do it in your calculator, you will get a big fat 0. So these are some just examples of a rational expression or an algebraic fraction. That means we have numbers and letters together. So we're going to look at simplifying these guys today. All right, so the domain, that's the x values or the input of a rational expression, is the set of all real numbers except the value or values of the variable that result in division by 0 when substituted into the expression. So to find the value of the variable excluded from the domain, set the denominator equal to 0 and solve. So we can actually figure out what numbers we cannot have by setting it equal to 0 and then solving it, and that tells us what we can't have. All right, so we're going to do some practice of that. So first up, it says to find the values excluded from the domain of each algebraic fraction. So what can we not have in the domain? So we can never divide by 0, so that's the one number we want to figure out what can't that be. So you take what the denominator is and you set it equal to 0, and then you solve for the variable. In this case, it's already solved, so x cannot be 0. And that's all we need for that one. Since it just asks for what's excluded, we don't have to write the domain. So if we had to write the domain, we would write it something like this. It's all real numbers except it cannot be equal to 0. So we'd have that little u excluding 0 from our answer. All right, for the next one, we're going to take negative 5y plus 9, set it equal to 0, and we're going to solve for y. So I'm going to subtract 9 from both sides, and then I'm going to divide both sides by negative 5. So I get y is equal to 9 over 5. So that means my domain, y, cannot equal 9/5. There's my answer to that one. And we put the little slash to the equal sign. That just means cannot equal. All right, let's look at the next one. We have a squared minus 3a. So I want to take a squared minus 3a and set it equal to 0. Now we have to draw on what we've learned in previous units. So we're going to factor this one. So you should always be looking for the GCF first. And they both have an a in common, so I can take an a out and I'd be left with a minus 3. And then, now that it's fully factored, I can set both of them equal to 0 and solve for a. So on the first one, it's already solved. On this one, I would add 3 to both sides. So we have two answers here. A cannot equal 0 or 3. All right, let's look at D. So we're looking at the denominator here. X squared plus 3x minus 28 is equal to 0. So we want to figure out what can x not be. Well, this looks like a simple ABC, so I want to factor it. So I have my x and my x. And I'm thinking of two numbers that multiply to negative 28 but add to positive 3. That would be positive 7, negative 4. And then I can take these two and set them equal to 0. And then solve for x in both cases. So x equals negative 7, x equals 4. So I have two answers. X cannot equal negative 7 or positive 4. So essentially, any of these values, if I substitute it, will give me a 0 in the denominator, and then that means I can't have it because I can't have a 0 in the denominator because I can't divide by 0. Right, so to simplify a rational expression means to write the fraction so there are no common factors other than 1 or negative 1. So basically you're reducing the fraction. And we can do this with polynomials, not just regular numbers. So we are going to factor the numerator and the denominator, and then we divide out all common factors. So just some refreshers, when we're factoring, we should always be looking for a GCF. There's simple ABC, which we just did an example of, ABC. And we have complex ABC, complex, and we have difference. Oh my god. Let's try that again. We have difference. Maybe if I say it slowly and it'll make it go right better. Difference of squares. And then the last one that we looked at way back in one of those previous units was our difference of cubes. Oops, this one is difference or sum because we can have addition and subtraction for this one. So I'm going to put both of those in here. All right, so those are our options when we're factoring. So we're obviously going to do a couple examples of simplifying when we have algebraic fractions. All right, so our first step was to factor everything in the denominator and in the numerator. So we're going to factor everything we can. So I'm going to take n squared plus 7n plus 10, and I'm going to factor that. This is simple ABC. So I'm thinking two numbers that multiply to 10 and add to 7. So hopefully you can do that in your head. I have n plus 5 times n plus 2. And then the denominator, again, simple ABC because the value in front of your squared is a 1. So two numbers that multiply to negative 15 and add to positive 2. So that would be n plus 5 times n minus 3. All right, so we factored it. And then the next step is to look at what can you cancel out? What's the same in the numerator and the denominator? Well, they both have an n plus 5. So these guys would cancel each other out. So I would be left with n plus 2 over n minus 3. So there's my answer simplified. The next thing it says to state restrictions on your variables. So what can n not be? This is where we have to take the denominator, what we did in the couple slides ago. So we've already factored this, so we don't need to factor it again. We just need to take everything and set it equal to 0 and then solve for n. So n cannot equal negative 5 or 3. So when you guys get to these on some practice problems, just make sure that you answer both parts. You simplify and then you figure out what can it not be. And just because you crossed it out, you still have to account for that in your domain because if you don't, then you're going to get the problem wrong. All right, so we only have 2 examples, so pretty short. So this one we have ab to the 6 times a squared minus 2a minus 15 over a to the 7th times b to the 5th times a minus 5. So we want to factor what we can. So this ab to the 6, I can't do anything with that, but the a squared minus 2a minus 15, I can factor that. So I'm just going to bring the ab to the 6, and then I'm going to factor this. So simple ABC, two numbers that multiply to negative 15 and add to negative 2. So that would be negative 5 and positive 3. And then this bottom one, the denominator, I can't do anything with that one. So I'm just going to bring it over. All right, now everything has been simplified. I'm going to start crossing out or canceling what I can. So I have an a and I have an a to the sixth. You remember your rules of exponents. So this is an a to the first power. So I have one a on top and 7 on the bottom. So that means I have 6 a's left, right? Because that would cancel. All right. Then I've got b to the sixth and b to the fifth. Well, I have 6 on the top and 5 on the bottom. So that means I'd have 1 left in the top. A minus 5 will cancel each other out. And then I'm left with a plus 3. So there's my answer, simplified. The last thing you want to do is figure out what are your restrictions. Well, think about all your variables. So I have an a, a b, and I have a minus 5. So I would do a minus 5 equals 0. So a equals 5. So I know a cannot equal 5. And you have to think about what if I were to plug in, because just think about this, if you plug in this 5, 5 minus 5 is 0, and then this is all multiplication. So I know you're probably thinking, well, I could plug in 5 here, but that wouldn't necessarily work out because if you multiply anything times 0, you're going to get 0, so that's why we can't have 5 in there. But then we also couldn't have 0 because this would give me a 0, and if I multiply this times that times anything would give me 0. And then we also have our value of b. b cannot be 0 because, again, this is all multiplication, so um, it would end up being 0, so we can't have any of that in there. So those are your restrictions for that one. So hopefully you think this is pretty simple and straightforward and easy. Um, as usual, write down any questions that you have and then bring them into class. So yeah, this is pretty quick. Peace, people.